All right, let's get into it. We are going to pull back the curtain on some of the most common but, most overlooked giants of our industrial world. We're talking about the secret life of a storage tank.
You've seen them, right? Clustered near refineries, dotted along highways, standing guard at airports. They are literally everywhere. But have you ever stopped and thought, what does it actually take to build one of these things? And maybe more importantly, how do you keep it safe for like 50 years or more?
Well, the answer isn't just a whole lot of steel and some welding torches. No, it all comes down to a rule book. A really dense, incredibly precise set of instructions written in the language of engineering. We're talking about two key standards from the American Petroleum Institute, API620 and API653. You can think of them as the DNA and the owner's manual for a tank's entire life.
So let's start right at the beginning, the birth of a tank. This whole process, from the very first design sketch to the final weld, is governed by one single document, API 620. This is the blueprint for a behemoth.
Now you have to understand these rule books are written with an almost legalistic precision. In day-to-day conversation, words like should and may are pretty flexible, right? But not here. In API 620, they have very specific, non-negotiable meanings. Should is a strong recommendation, but it's not actually required. May, on the other hand, defines an action that is explicitly allowed. This kind of precision is absolutely critical, because there can be zero ambiguity when you're building something that needs to last for decades under pressure.
And that precision, it extends to the materials themselves. You can't just use any old steel. API 620 gives you specific tables, just like this one, that tell you exactly what kind of steel you can use, and, this is the important part, its maximum allowable stress. That's how much force per square inch you can handle before it's at risk of failing. Engineers have to pick materials from this list based on some very precise calculations for what the tank is going to hold and where it's going to be.
And get this, they don't just design the tank to hold liquid. They have to design it for its absolute worst day ever. API 620 actually forces engineers to calculate the most severe combination of forces that could hit the tank all at once. So we're talking about the weight of the steel and the liquid combined with gas pressure from the inside, wind pushing on the outside, a heavy snow load on the roof, and even earthquake forces, all at the same time. Here's a concept that just shows you the insane level of detail we're talking about. It's called welded joint efficiency. See, welding isn't just about melting metal together. Engineers use this factor, which is usually a number a little less than 100%, that basically admits that even a perfect-looking weld might have some tiny allowable flaws. So they build this slight reduction in strength right into the design math from the very beginning. It's like a built-in safety cushion. This level of care is just incredible. It even extends to how the metal cools down. For really thick pieces of steel, the act of welding creates these immense internal stresses. So, to fix that, they go through this meticulous process called stress relief. The part gets put in a giant furnace and heated slowly up to 1100 degrees Fahrenheit. It's held there for hours and then cooled down just as slowly. This whole process just lets the metal relax, getting rid of those internal stresses and making sure the final piece is uniformly strong.
Okay, so the tank is built. It's strong, it's ready. But its story has really just begun. Now comes its long life in service, and it's a life under constant pressure. And this is where that second rulebook, API 653, comes into play.
From the very first moment it's filled, that tank begins a quiet, decades-long battle. It's fighting against the slow, relentless attack of corrosion, both from the inside and the outside. It's enduring the stress of being filled and emptied over and over again, and it's even resisting the slow, invisible settlement of the ground underneath it.
And the tank's number one enemy, by far, is corrosion. But engineers don't just guess how bad it is, they measure it. The corrosion rate is a very specific calculation laid out in API 653. By tracking exactly how fast the steel wall is getting thinner, they can actually predict the tank's remaining safe life and figure out precisely when it needs an inspection or repair.
The rules in API 653 get so specific. I mean, right down to the fraction of an inch. Take this number, 3/16 of an inch. That is the absolute minimum thickness allowed for a new steel plate on the roof of a tank. It might not sound like a lot, but that one measurement is totally non-negotiable. Every single part of that tank, from the floor to the roof, is governed by these kinds of precise minimums. There is just no guesswork allowed.
So, if a tank is in this constant battle, how do we make sure it's winning? Well, it's time for the tank doctor to make a house call. This whole process, the inspection, the diagnosis, and the repair, that's the real heart of API 653.
And this doctor has a very specific title, an authorized inspector.
Now, this isn't just some person in a hard hat. This is someone who has gone through a really tough certification process to prove they have the expertise to check the health of a tank according to these incredibly exacting standards. They're basically the guardians of the tank's integrity.
So how in the world do these inspectors see inside solid steel? Well, they use tech that's actually pretty similar to what you'd find in a hospital. Radiography is like an industrial X-ray. It creates a film image that can show tiny cracks or voids deep inside a weld. And ultrasonic examination? That's kind of like a medical sonogram, bouncing sound waves through the steel and detecting flaws by listening to the echoes. This lets them find problems without ever having to damage the tank. Now, during an inspection, some areas get way more attention than others. API653 defines something called the critical zone, and it's a very specific area, a 3-inch wide ring on the tank floor, right where the wall meets the bottom.
So why all the focus on this one little 3-inch strip of metal? Well, because this is where the physics gets really intense. The entire weight of the steel shell, we're talking hundreds of tons, plus all the stresses from the liquid pressure, it all gets concentrated and transferred to the foundation right through this narrow zone. And that makes it a major hotspot for things like fatigue, cracking, and corrosion.
Because this zone is so vital, repairing it is just a masterclass in being cautious. It's not just do one weld and you're done. Nope. The process is multi-step and redundant. So the first layer of the new weld gets a visual check, then it gets tested. After that, the final layer of the weld gets a visual check, and then it's tested again. It's this total belt and suspenders approach that makes sure a repair in the most critical area is absolutely 100% sound.
So, we've followed this industrial giant from its conception all the way to its middle age and its regular checkups. Let's pull it all together now and look at the entire life cycle from start to finish.
This timeline really shows the whole journey. It starts with that blueprint, the design and build phase under API620. Then it enters service, where it starts getting monitored under API653. When issues pop up, the tank doctor comes in and makes repairs, all according to the rulebook. And after a super thorough inspection and any work that's needed, it gets recertified. It's declared fit for service, ready to continue its life safely.
And if you take away just one thing from all this, let it be this direct quote from the standard itself. The rules given in this standard are minimum requirements. Think about that. All of these complex, incredibly detailed rules, they are not the goal. They are the absolute bare minimum, the starting point for safety.
At the end of the day, these structures aren't just big, static containers sitting there. They are highly engineered, dynamically managed systems. You could even say they are living a life that's governed by a constantly evolving set of rules, all for one single purpose: to safely store the materials that literally fuel and build our modern world.
So, the next time you drive past one of these silent giants, what are you going to see? Are you going to see a simple steel can? Or are you going to see a carefully designed, meticulously built, and constantly monitored marvel of engineering? A silent guardian that's being watched over every single day to keep all of us safe.